Cereal rye cover crops, an increasingly hot topic in the agricultural community. Whether it is the soil health or the weed management capabilities that interest you, there are many different agronomic benefits that are often challenging to accurately quantify. Hi, my name is Jacob Felsman, and I'm a graduate student here at the University of Wisconsin-Madison in the Department of Plant and Agroecosystem Sciences. My research specifically focuses on the implementation of cereal rye cover crops in the corn and soybean rotational systems. Now, there are many different management factors that must be considered when adopting a cover crop, and these decisions may have an impact on agronomics as well as general soil health and structure. In this video, we will discuss how we can accurately quantify soil health parameters when we prioritize both weed and soil management practices in a cereal rye cover cropping system. To help answer many of the questions that arise around this production practice, a field experiment was established in the fall of 2018, otherwise known as the systems trial. This experiment is located at the Arlington and Lancaster Agricultural Research Stations in southern Wisconsin. The 2023 growing season marked its 5th continuous year in a corn and soybean rotation. This study is comprised of 6 different soil management treatments under 2 herbicide programs, which represent the most common agronomic practices here in Wisconsin, with 6 different soil treatments, which include a conventional till, no-till, and 4 different cereal rye cover crop scenarios with different termination timings. Our cereal rye terminations occurred 14 days before, at, and 14 days after cash crop planting, with our last cereal rye scenario being a forage harvest of rye occurring at planting. The herbicide portion of this study is split into 2 scenarios, our first scenario being a post-herbicide application only, and our second being a pre-herbicide with residual activity followed by a post. To assess soil health, we followed guidelines set forth by the Soil Health Institute, which highlights the 4 parameters needed to have a good measure of general soil health. Recommended parameters included organic carbon concentration, carbon mineralization potential, aggregate stability, and water holding capacity. Following this procedure, we collected 3 different samples from each experimental plot of this study to use for the assessments required. The first was a composite sample, which was collected to a depth of 15 centimeters with a 2.5 centimeter diameter probe. Samples were collected at random 10 times across each plot and were analyzed for organic matter, which allowed us to infer soil organic carbon concentration. The second was for bulk density, which one 5 centimeter deep sample per plot was collected with a 5 centimeter diameter slide hammer probe. These samples will tell us the overall density of our topsoil in regard to water holding capacity. For our last sample, which was aggregate stability, we collected clumps of soil from the first 5 centimeters of topsoil. These samples allowed us to infer biological and chemical strength of our soil aggregates, as well as to measure carbon mineralization potential via soil respiration. Soil samples were collected in between vegetative growth stages 2 and 3 of each crop. Once collected, samples were shipped to soil analysis laboratories to be processed. The results that we have currently received and analyzed are our soil organic matter, which is derived from our composite sample, and bulk density, which we collected with our slide hammer probe. Our aggregate stability samples are still being processed. However, the data from bulk density and soil organic matter show that there are no major differences between our soil management systems for either parameter. Despite the results that we found, we still observed beneficial weed suppression in all soil management scenarios, which included a pre-emergence herbicide that had residual activity. But what we can conclude is that 5 years is simply not long enough to see statistical differences in bulk density or organic matter across soil management. Now, regardless of what your cover crop and/or soil management practices are, patience is crucial because improving general soil health is a long-term game. I'm Jacob Felsman, and thanks for watching.